Welcome to Surveying Technology assignment video number 3. Let's go ahead and get started by opening our existing folder that we created that houses all of our previous projects. I have it open right here. We'll go into Surveying Technology assignments. And let's go ahead and create a new folder for this week's assignment. And we're going to go ahead and name this folder Autodesk Civil 3D. Creating topo maps. Okay, let's go ahead and find last week's project, which was working with lines and points. We're going to go ahead and copy the project to our new folder that we just created. And we want to rename the project. So we're going to rename it. It's going to be the first initial of your first name and then your full last name. And then it's going to be Civil 3D creating topo maps. Fantastic. Okay, once we have that created, let's go ahead and open Civil 3D. And we will open that file. We'll navigate to that. And we'll go ahead and click open. Alright, just like last week, it will open in exactly the same place that you closed it. So let's go ahead and go to our Model tab. In order to create a topo map, first we have to create a surface. In order to create a surface, we're going to come over to the Prospector tab, and we're going to, right here in Surfaces, we're going to right click and we're going to create a surface. And this dialog box will pop up. We can leave this setting the same. We can leave the surface layer as cTopo the same. Let's go ahead and input the surface name. I'm going to call this topo map. And then we can leave a description. I'm just going to say topo map again because I know that that's what this surface is going to be. So after that, we can leave everything else the same and we can click OK. And the surface has been created. And over here now you see in the Prospector tab, Surfaces has a little plus next to it, and that will expand the surfaces that are in this drawing. And the surface we just created is called topo map. So let's go ahead and expand that surface as well. And you can see now within the surface there's masks, watersheds, definition. We want to be able to see all of these three here. So throughout this project we'll leave topo map open. One last thing that we want to do is we want to right click on topo map and do rebuild-automatic. And if you right click again, you'll see a little check mark next to it. This means that anytime we make a change to the surface, it will automatically update the surface. This is good because there are times when you would have to manually update the surface. Sometimes you may want to leave this off, and let's say you're making a large number of changes to the surface and you don't want it to update immediately after each change. You want to do it in batches, just in case you were to make an error, you could fix the error before the surface updated. But in this case, we are going to be working with a small amount of surface data, and for our convenience, we want it to rebuild automatically. Let's add some points to create the surface. So to do that, we're going to come over here and we're going to expand this definition button under the surface we created, the topo map surface. In order to do that, this is where the point groups that we've used previously comes in really handy. We're going to click on point groups and we'll right click on it and we'll click add. And then this little dialog box will pop up right here. And the way that surface creation works is it takes the data that you provide for the definition and it basically connects all the little dots. It draws lines between them, and we'll see that as we delve deeper into the surface creation today. But we need to add all the point groups that we want to use for this surface. Now, in selecting the point groups that we want to use, we need to think about what the end goal of this map is going to be. In this case, we're trying to provide topographic data of the ground itself. So we may not want to include things like curbs if they were in the surface. The elevation of our curb is not going to be the same as the elevation of the ground that we took topographic data of. So we just want to think through that as we include the points. Something that we can do here is that we can look and see, let's see, what is part of this surface here? Well, I see all these topo points. We most definitely want this to be included in our surface. Let's see what else we have. We have trees. Now, since I did the survey, I know that the trees, when I took the tree data, the trees aren't in any type of special planter. They're directly on the surface. So I can include the trees and it will be part of the data. Same with the irrigation box. I know that that is part of the surface where I took it. Now, sidewalk edge, I don't necessarily want to include sidewalk edge because this is more of a boundary for us, and we'll use that to create a boundary later. I don't really want to include post because I'm just trying to create a topographic map of this area right here. So the groups that we're going to include here are topo. We'll include, well, actually we might not want to include tree because we have some trees all the way out here and that could skew the surface data. So let's just include topo and irrigation box. Okay, so we'll just do topo and irrigation box. So point groups, we will add the point groups. So we'll do topo, and then to select more than one point group in Civil 3D, press and hold down Control while clicking again, and it'll allow you to select multiple. So topo irrigation box, we'll click OK, and you'll see here now that as soon as we did that, the topo map, it generated this surface based on the point groups that we have added. Now we want to create a boundary for this topographic data. We can see here that this topo map is coming past and coming through this sidewalk edge line that we have going on right here. And that isn't necessarily an accurate representation of what's actually happening in real life. And we can also see over here, really the map, we kind of want it to extend out to here because of the data that we have available. But because Civil 3D, the extent of the data that we gave it was, hey, we have this data point over here that you can connect to. That's as far as it was able to take that data. So we're going to do a couple different things here. The first thing that we want to do is we're going to need to physically draw the boundary on the map that we want to connect to. And the best thing that we're going to want to do that is the same as when we drew the sidewalk edge. We want to create a new layer so that we can turn the boundary on and off based on whether we want to see it or not. So here I clicked the layer properties tab, and this is just like we created a boundary last time we were working here. Remember, when you create a new layer, it's gonna create it based off whatever the previous layer was that you used when you click the new layer button. And I'm looking for something that says BNDY because most likely I will like whatever properties are used for this layer. So here we can use this one, and I can create a new layer, and let's name this layer. We'll do an underscore on it first because remember, the underscore will keep it at the very top of the list, and we want to name this layer TOPO for topographic dash BNDY, topo boundary, and that'll create the layer. And then let's change the description. So I'm just gonna call this the boundary for topo map surface, because that is all that we'll be using this layer for. Okay, there we go. And then we need to set this layer as the current layer, so I'm going to double click on it. Fantastic. Okay, so this is now set as the current layer, which means that anything that we do, any lines we draw, will be drawn on this layer. So now we need to draw a 3D polyline that will actually be the boundary that we'll use. So let's start by typing in 3D poly. I'll hit enter, and the boundary that I want to use here is I'm going to connect the sidewalk edge just like we did last time. Now some of you may ask, well, why can't we just use the line that was already existing for the sidewalk edge? Well, you could copy the existing sidewalk edge and move it onto the topo boundary layer, and then you could close it off because these boundary lines need to be in a completely closed loop. That means that if you were to draw the boundary and leave one end open, Civil 3D would kick back when you try to create the boundary and say, actually, no, sorry, we can't do that. This line's open-ended. We don't know where the boundary actually extends to. So that means in this case, on the sidewalk edge, I have an end here that I need to somehow connect back to this other end in a natural way. And in this case, I'm just going to come to the edge of these topo points, and we'll come here, and you know what, I'm gonna come, you know what, we'll come out to this light pole here, we'll come over here to this light pole, and then I want to connect back to the sidewalk edge here. Okay, Fantastic. And I hit escape to end, and if I click on it and select this line that I drew, we can see that it is one complete closed loop. So something that we're going to do here before we actually create the boundary is we're going to have Civil 3D do what's called a break line. Now we'll use a break line specifically for this sand pit in a second to help stop this contour line from cutting through the sand pit. But we're going to use a break line in this instance because Civil 3D, remember, it connects the surface to whatever points it has. And when we insert a break line, it tells Civil 3D, hey, you must connect this surface to the break line. So in order to do that, we're going to select the 3D polyline that we drew as the boundary, and we're going to come over here in the Prospector tab under Definition, go to Break Lines, and click Add. Okay, and then the Add Break Lines dialog box comes up, and we're just going to go ahead and name this Topo Area Extent, because this is going to be the extent, the extents of the data here. All right, and then once I click OK, watch what happens. You'll see that now the surface comes and it fills the entirety of this break line area. It said we need to fill everything that's inside this break line. So that's what it did here. And we can see in some areas it didn't necessarily do that also well. It said for this topo, we don't necessarily have enough data to come out to the break line here, but that's all right. It is much improved over what we had happening previously. So now we can add the boundary. The process to add the boundary is much the same. We select the break line right here. And once we have selected the break line, we're going to come over here in the Prospector tab, and we will right click on boundaries. We will click Add, and the Add Boundaries dialog box will show up. Now there's a couple different options here. After you name the boundary, there's outer, show, hide, data clip. In this case, we're just going to use outer. I'm not going to explain the others. You can go ahead and play around with them on your own if you'd like, but we're going to go ahead and name this boundary Topo Boundary, because that is what it is. It is just the boundary of our topography here. And this is super simple. I'll hit OK, and now watch what happens. The surface that was extending out here onto the sidewalk edge has now been pulled inside this boundary line. So it is now constrained within our boundary line here. Just like we used a break line to help tell Civil 3D that the data needed to be expanded outward towards that break line, we're going to use the same principle to tell Civil 3D that, hey, this right here, this contour line going through this sand pit right here isn't necessarily accurate, because the sand pit, we can see here, the elevation of the bottom of the sand pit is 997.26, whereas over here, on the field itself, it's 999.78. So we have about over a 2-foot difference between these 2 points, and this contour line isn't really exactly showing us what we want to see here. So the first thing that we want to do is we want to create another new layer specifically for this this break line for the sandpit edge. So let's go to layer properties here, and we're going to create a new one, and I'm going to see if there's something for break line. No, maybe necessarily not. So in this case, I'll just choose one. Let's do something. We can just use the same that we did for topo boundary. So we'll create this new layer and we'll name it underscore sand. We'll name it underscore sand dash pit dash BKLN. Great. Now we want the color to be slightly different, just because when we're drawing and we're drafting within Civil 3D, it can get confusing if things are the same color. So to change that, just double click on the color here and choose whatever color you want. Now remember here that the color that you choose, it will be that color when you try to plot. So we want to make sure that the color we choose is something that's visible to be seen. I'm gonna come over here and, you know what, let's do cyan. Okay, and let's double click this to set it as the current layer. And we can see here it's the current layer, so we're good to go. So let's draw another 3D polyline. 3D poly. and we just want to draw around the edge of the sand pit. So follow along with me here, connecting these points. Now when you get in here, it can be a little bit confusing. This is the edge of the sand pit. This is not the edge of the sand pit out here. This is just another topo point we took. So these all right here are the edge of the sand pit. We'll just draw along like this. Fantastic. Okay, and you can escape to stop. And we'll click on the 3D poly that we drew, and fantastic, it is one continuous line. Let's go over here to break lines. We're gonna hit add, and we can call this break line sand pit edge. Okay, and we hit OK. Now, when we did that, you might say, well, it doesn't look like anything's changed. Well, yes, that's true. That's because we actually have to physically go in to Civil 3D and tell it what it can or what it should and should not connect to at this point. In order to do that, we need to select a contour line on the surface, and it'll actually turn on the surface. It'll select the surface itself. And by doing that, this tin surface topo map, this tab in the ribbon shows up, and we need to come over here to surface properties, edit surface style, and the surface style dialog will show up. And we need to come over to display. Now it may start over here in information, come to the display tab, and we need to make triangles visible. So click on the little light bulb right there. And now you can see here, all of these little triangles right here are actually what connects us point to point. This is what tells Civil 3D, hey, this point's connected to this point, so you have an elevation change across this area over here. Now, in order to tell Civil 3D to stop putting a contour line through the sand pit, we actually need to disconnect these points from each other. We need to change the triangles. So in order to do that, we will select the surface by clicking on either a triangle or a contour line, and we will click on Edit Surface, and we're going to click on Delete Line. So the way that this works here, and this might take some trial and error on your end, is you want to delete only the lines inside here that connect the points to each other, that connect these inside points, which is really what the error is here, is we have inside points connecting to outside points. We want to delete those lines. So I'm just going to go around and I'm going to select all the objects, and it will select multiple automatically. And we only want to select the ones that are connecting point to point. And we want to try to get them all at once, because if we don't, some weird things might happen, and I can show you. So this is what all of them look like. Now I can hit enter, and you'll see now that there's no triangles inside there. So let me escape and let me undo that, and I can show you what happens if we don't remove all of them at once in the right way. Oops, see? So I accidentally selected a break line right here. If you want to deselect something, hold down shift and click on the object you selected, and you'll be able to deselect it. So let's say I just delete these lines right here. Now you can see what Civil 3D has done is it has said, well, now that there's no data connecting these points together, we'll just connect what we have, and we'll just put in a little boundary right here, an inner boundary that says, well, there's nothing here. And this can get a little bit trickier if you let it do that, because now when I start to delete lines, here, let me delete these, and we'll see what happens. Now when I start to delete lines, let me find another one. That wasn't a very good example. Here we go. Here we go. Now it starts to get a little bit weird, and it's tough to delete this one. This triangle doesn't want to delete. So that's just an example. If that happens to you, it may be easier, rather than trying to find all the lines, to just use Control-Z to undo the process, and then just go back in and try to get all the lines at once that you need to do. And then you can press escape to exit the selecting line or deleting line tool. So now that we do that, we just need to come back and let's turn off the triangles. So surface properties, edit surface style, display, make sure that the triangles are no longer visible. And now we can see really clearly and make sure that there's no contour line going directly through the center of that sand pit. Something that we might want to do to our surface after it's created is change the contour interval, meaning how often it shows the elevation changes visually. To do that, we're going to select the surface by clicking on a contour line or another part of the surface definition, a boundary, break line, etc. And we'll go to Surface Properties, Edit Surface Style, and this will pop up here. And we want to go to the Contours tab. And I'll put this over here so you can see what happens. So within the Contours tab, there's a lot of different options, and you can play around with these. But one that we're going to change specifically is contour intervals. And we want to change the major interval to 5 and the minor interval to 1. And you can see sometimes when you change the numbers, because of the presets that are in Civil 3D, it doesn't know exactly what you're trying to do, so it'll try to guess, and you might just have to just adjust the number again. So I'm going to hit apply and see what happens, and you can see that now over here it shows the contours, it shows more of them, meaning now that every 5 foot it shows a major interval change, and now it shows every 1 foot of change here. And if we zoom in, we can see that these major ones, and it may be more difficult to see, these major ones are a little bit lighter white, right? So this means that there's 5 feet between those two, and the minor intervals are these little gray ones. So we have a 5 feet here, and there'd be 1, 2, 3, 4, and another 5 foot major interval change. Something else that we want to do to the surface is we want to smooth the contour lines. Now, smoothing the contour lines is visual mostly. In situations where you need to have the utmost precision in terms of being able to display exactly what is being shown, then you may not want to use contour smoothing. But in this case, we want to use contour smoothing because we don't have the most amount of data here. For example, there's a big gap between this topo point and this topo point, and you can see here that Civil 3D says right here, it says, well, right here there is a sudden drop. It would say, hey, between this point and this point it's about a 1/2 foot drop. And 1, it doesn't look very good, and 2, it's not exactly the most accurate. So what we're going to do is we're going to open the contour smoothing box, and we want to change smooth contours from false to true. And I'll hit apply, and you'll see things start to smooth out. And then if I adjust this contour smoothing slider right here, it'll adjust the smoothness of the lines. So go ahead and play with that. Go ahead and smooth it until you think it looks good. Let's go ahead and add contour labels. So contour labels will have a number on the line showing exactly what the elevation is at that contour line. Civil 3D makes this really easy. What we're going to do is we're going to come over to annotate, hit the add labels drop down, surface, contour multiple. So when you do that, now your crosshairs show up, and you're going to come to a starting area, and I'll come down here and you click. And now you'll see a dotted line show up, and watch. We'll take the dotted line and we'll drag it to where we want to go, and then we want to click and see it added some contour labels here. And where I clicked, it'll add a vertex, so we can go a different direction, because I would end up going straight through the sandpit and that one looks so good. So you know what, now we can come over in this direction, and then when I've got all the contour lines that I want to label, I can hit X. Fantastic. Now I can see very clearly what the elevation is of each of these contour lines. But something I don't particularly like here is having this line that goes all the way through the map. It cuts straight through the details for this point, and I don't necessarily need it. So something that we can do here is we can select this contour group, and if we type PROP, properties, it'll bring up the properties box for this in particular, and mine keeps showing up on a different screen. So in the properties box here, if you come to display contour label line and change that from true to false, now that line will disappear. And you can change other things here, masking. You can play around with these and figure out what exactly each one of them does. But now there is no line going through these contour labels. Something that you may need to do, let's say that this contour line was over here, and it's cutting directly through a point. So what we can do is we can move the group of lines or the group of labels I should say, so that they are not obscuring our vision of any of the other data here. Now that we have our topo map created, this looks fantastic. We just need to prepare it for printing. So let's go ahead and hide all of the points in the trees, because that's not really the focus of the map here. So we're going to do point groups, right click on point groups, properties, and remember, if we move the all points point group to the very top of the list and hit OK, the points will disappear. But for the trees, we need to go home, layer properties, and we need to freeze the vnode-tree layer. And now the trees are gone. So now we have just the map here. And this is good. We want to leave the sidewalk edge on because it's descriptive, and the sandpit edge here. But something else we want to do is we want to freeze the topo boundary layer. We don't want to see this boundary. So let's go and topo boundary. We can go ahead and freeze this. And you see, even though we froze that boundary, we see another different type of boundary here. And in order to turn that off, you have to select the surface, go to surface properties, edit surface style, and then under display, we need to turn off border. And then hit OK, and that border goes away. And this looks much better. It looks much cleaner. So at this point, let's save the project by doing Control S, the command Q save, or hitting the save button over here. Let's go to layout 1. And if we zoom out, we can see that this looks great right here. Something that we need to do is let's go ahead and change this text to say topo map. Oh, and we want that capitalized. Great. Oh, and I clicked inside the viewport. And something we want to do, especially if you accidentally click inside the viewport when you're trying to scroll out, is we want to scale to fit. Double click, right? That looks fantastic. Let's go ahead and press plot right here. Continue to plot a single sheet. 11 by 17, fantastic. Let's preview this. This looks great, and this is exactly what we want it to look like. So let's go ahead and hit the plot button here. And we're going to save this PDF. First initial, last name, underscore, underscore, Civil 3D creating topo maps plot. Fantastic. So we'll hit save. And let's go ahead and take a look at it. So we have it opened up here now. And once again, it plotted sideways, but that's not a big deal. And we can see, looking at it, that's fantastic. We have all the lines here, and you can see the major and minor contour lines. So this is an even better example. See, so 980 feet, this is the elevation, to 985, so that's a major line, and then each of these minor ones show up. And then I can see here the sandpit edge, and we can see the sidewalk edge. So this is fantastic and ready to submit.